Hello, grade 8. In this lesson, I will answer questions from end of chapter questions and from your workbook. You will find the key answer for questions 1 to 19 attached with this material, and I will answer question 20 from the end of chapter questions with you. The first graph is a distance-time graph showing the motion of an object. Pay attention, this is a distance-time graph. We have time in seconds, distance in meters, and we can see that the graph is a straight line sloping upwards. Describe the motion shown for the first 2 seconds, calculating any relevant quantity. So if we look here, the graph line is straight and sloping upwards. This means that the motion is steady. So speed is steady. Calculating any relevant quantity, this means that we need to calculate the speed. Remember that from distance-time graphs, we calculate the speed by calculating the gradient of the distance-time graph. And the gradient in distance-time graphs is the distance traveled, which is represented by this line here, divided by the time taken, which is represented by this line. So speed equals distance divided by time. The distance traveled here in this graph is 5 meters divided by the time, 2 seconds equals 2.5 meters per second. So the speed is constant and steady, and it's 2.5 meters per second. After 2 seconds, the object accelerates. Sketch the possible graph for the next 2 seconds. So the object now is going to accelerate. Remember that in distance-time graph, acceleration is represented as a curved line, and it's sloping upwards. So now we need to draw a curved line that goes upward for the next 2 seconds. They did not specify the change in speed, so all you have to do is just curve your line until okay. Describe how a distance-time graph shows an object that is stationary. Remember that in distance-time graph, a stationary object will be represented as a straight horizontal line parallel to the x-axis. So straight horizontal line parallel to the x-axis. Part B of this question, this graph is a speed-time graph. Now, we are required to represent the motion from the first graph, which is in the distance-time graph, on the speed-time graph. Draw the graph of the motion for the first 2 seconds as shown in the first graph. Okay, let's now notice that the motion for the 2 seconds in the first graph is a steady speed, and we already calculated this speed as 2.5 meters per second. So this means that this object starts moving at a steady speed of 2.5 meters per second for 2 seconds. How are we going to represent this on a speed time graph? Remember that a steady speed on a speed time graph is represented as a straight horizontal line. Now we already have the speed, which is 2.5 meters per second, and we know the time, 2 seconds. We need to represent this on the speed time graph. So Now the divisions between the speed values on the y-axis are 5 divisions, and the difference is 2 meters per second. So the value of each grid is 2 divided by 5, 0.4 meters per second. So each grid is 0.4 meters per second. We need to find the 2.5 meters per second. This is 2.4 here, so 2.5 is in the middle of this grid here. In order to represent this journey on a speed time graph, we need to show that the object is traveling at this steady speed of 2.5 for 2 seconds. So this will meet with this point here, the 2 seconds. We draw a straight line with a ruler. So this straight horizontal line represents the steady speed of this journey. Draw an extension of the graph for the next 2 seconds, showing the object accelerating at 2 meters per second squared. So now, for the next 2 seconds, until 4 seconds, we need to draw an extension of this graph, showing the acceleration of 2 meters per second squared. So we need to know how are we going to plot this graph. So now the speed, or the initial speed, starting here is 2.5 meters per second. We need to know what will be the final velocity after 2 seconds pass, traveling at an acceleration of 2 meters per second squared. So we know the acceleration, A, 2 meters per second squared. We know the initial velocity, u, 2.5 meters per second, and we know the time, 2 seconds. Now, in order to draw the line, we need to plot a point between the time, which is 4 seconds now, and the final velocity, which we're going to find using the formula of acceleration. Final velocity is unknown. So acceleration equals v minus u divided by time. Acceleration is 2 meters per second squared equals final velocity v minus 2.5 meters per second divided by time, 2 seconds. So this becomes 2 multiplied by 2 meters per second squared equals v minus 2.5 meters per second. V equals 4 meters per second plus 2.5 meters per second equals 6.5 meters per second. So the final velocity is 6.5 meters per second. So we need to plot a point between 4 seconds and 6.5 meters per second. So acceleration will appear as a straight line sloping upwards from this point. D. Describe how speed-time graph shows an object that is stationary. In speed-time graphs, an object that is stationary means that its speed is 0 meters per second. So it will appear as a straight line at 0 meters per second. A straight line, straight horizontal of course, line at 0 meters per second, and this will appear directly on the x-axis. Exercise 2.5, acceleration from your workbooks. In an advertisement, a car is described like this. It can accelerate from 0 kilometers per hour to 80 kilometers per hour in 10 seconds. By how much does its speed increase in each second on average? So here we don't need to do calculations. Notice that in 10 seconds, the speed increases from 0 kilometers per hour to 80 kilometers per hour in 10 seconds. This means that on average, each second, the speed will increase by 8 kilometers per hour. So the speed increase in each second is 8 kilometers per hour each second. A cyclist is traveling at 4 meters per second. She speeds up to 16 meters per second in a time of 5.6 seconds. Calculate her acceleration. Okay, in order to calculate acceleration, we need initial velocity, u, which is 4 meters per second. Final velocity, v, 16 meters per second. And time, 5.6 seconds. This will allow us to calculate acceleration. Acceleration equals v minus u divided by t. V is 16 meters per second minus 4 meters per second divided by 5.6 seconds. 12 meters per second divided by 5.6 seconds equals 2.1 meters per second squared. So acceleration is 2.1 meters per second squared. C. A stone falls with an acceleration of 10 meters per second squared. Calculate its speed after falling for 3.5 seconds. So, when the stone falls, it starts from an initial speed of 0 meters per second. So we know that u, the initial speed, is 0 meters per second. Calculate its speed after falling, so we need to calculate the final velocity. We know acceleration, 10 meters per second squared, and we know time, 3.5 seconds. We need to calculate final velocity. So u equals v minus u divided by t. Acceleration actually equals v minus u divided by t. Acceleration 10 meters per second squared equals v minus 0 divided by the time, 3.5 seconds. So v equals 10 meters per second squared multiplied by 3.5 seconds. Second is eliminated by 1 second. And the final answer is 35 meters per second. So the speed after 3.5 seconds is 35 meters per second. D. On the moon, the gravity is weaker than on Earth. A stone falls with an acceleration of 1.6 meters per second squared. So it's faster. How long will it take to reach speed of 10 meters per second? Here we also know that the stone will fall from an initial velocity of 0 meters per second. Its acceleration is 1.6 meters per second squared. Time is needed to be calculated, and the final velocity is 10 meters per second. We need to calculate time. Again, acceleration equals final velocity minus initial velocity divided by time. 1.6 meters per second squared equals 10 meters per second minus 0 meters per second divided by t. So time equals 10 meters per second divided by 1.6 meters per second squared. Time equals 6.25 seconds. So it needs 6.25 seconds to reach a velocity or speed of 10 meters per second. Exercise 2.6, speed time graphs, page 18. In this exercise, you draw and interpret some speed time graphs. You can calculate the acceleration of an object from the gradient slope of the graph, and you can calculate the distance traveled from the area under the graph. The diagrams A to D show speed time graphs for 4 moving objects. Complete the table by indicating in the second column the graph or graphs that represent the motion described in the first column. So we have 4 graphs. Speed time, they are all speed time graphs. Here we have a curved graph line going upwards, then going downwards. A straight line going upwards, then curved and becoming horizontal. A straight horizontal line and a straight line sloping upwards. Description of motion. Which graph line represents an object moving at a steady speed? The graph line that shows a horizontal straight line is the one showing a steady speed, so C. Speeding up, then slowing down. So, graph A is showing an object that's accelerating, graph line sloping upwards, then decelerating, graph line sloping downwards, so A. Moving with constant acceleration. Moving with constant acceleration means that the acceleration is steady. Acceleration is a straight line sloping upwards when it's constant, so D. Accelerating to a steady speed. This graph line shows an object that's accelerating, then it's becoming horizontal and straight, so it's becoming steady speed, so graph B. In section B, we're going to calculate the distance traveled for this journey from this speed time graph. The graph represents the motion of a car that accelerates from rest and then travels at steady speed. So the distance traveled is the area under graph. We have 2 areas, area A and area B. Area A is a triangle, area B is a rectangle. So distance traveled equals area under graph. It equals area A plus area B. So area A equals area of triangle half base by height. The base here is from 0 to 15 seconds. So half multiplied by the base, 15 seconds multiplied by the height. No, the height is 24 meters per second. So area A is 180 meters. Area B is an area of a rectangle. It equals width multiplied by height. The width starts at 15 seconds and ends at 40. So the width is 25 seconds multiplied by the height, the same height, 24 meters per second. The answer is 600 meters. Now the distance traveled equals distance traveled in area 1 and in area 2. So equals 180 meters plus 600 meters and the total distance is 780 meters. That's it for Unit 2, describing motion. If you have any questions, please don't hesitate to ask me. I want you to go back and rewatch all the lessons, take notes, and see if there is anything that's not clear for you. I'm ready to answer all your questions. The views on the lessons are not enough. Not all of you are opening the lessons and you're not watching them enough. You have to go back, watch the lessons in order, and see if everything is clear. I'm not going to post any lessons for next week. You will have time to revise and study. And please ask me and don't hesitate to send me your questions. Thank you and good luck. I miss you so much and hope to see you very soon.